We're recording. Well, let's jump into it. We should have some more people jumping on, but let's get into it. I don't really have any announcements today for class or anything. Today we're going to be going over all things compass. So there's what types of compasses, compass error, and plotting those things on the chart. So we will get into plotting the second half of class. And today we're going to be plotting on the San Pedro channel chart. So not the training chart today. We get the real life one. And then the homework assignments, hopefully we'll get through the whole plotting one in class, and then the other two you don't need a chart for. They're just practice of compass error. So that'll be good. Any questions before we get started? All right, has anybody worked with compass error before? Deviation, variation, that kind of thing? Pretty new to everyone? Right? All right.
Yep. Just know it exists.
It exists.
But not much. Just in a very raw way.
Yeah, it exists out there. So now we're going to learn about it today. So let's go to PowerPoint. Right. Over here. All right, so you guys can see my PowerPoint, right? Yeah? Okay. Hope so. All right, we're going to be talking about compass corrections, compass error, and then we're going to touch on relative bearings and LOPs. But we do have, I think it's not next week, but the next week after that, we have a whole week dedicated to lines of position and LOPs. We're just going to touch on it so we can adjust the compass error on them today. But we will get into the nitty-gritty details about that in 2 weeks. So we'll go for a compass. So most of us know we have, north, east, south, and west. And how we use this on board is by putting a value to all of those numbers. So we have, 360-degree circle. So north is going to be our 0. That's kind of our reference point. 090 is east, 180 south, 270 west, and so on. So those are the numbers when we're talking about a compass, bearings, whatever sort of direction, azimuth, all those kind of little labels. It's all in reference to north as 0, and then we go clockwise around the circle to get our 360 degrees. So again, we have very accurate way of saying what something is, bearing or what our heading is. It can be very accurate where, let me skip that one right there. Back in when they first started sailing, maybe not even when they first started sailing, back before we had 360 degrees, we had cardinal points. So they would split up the compass, and I touched on this last week. I couldn't remember the number. 11.25 degrees per point. That's what it turns out to be now. But before, instead of 360 degrees, they had 32 points around the compass, and they divided them by their letters, by north by west, north northwest, northwest by north, northwest, etc., all around the compass. So they used to have 32 points, and now we have 360. So much more accurate these days, but we use the number system. So again, we have our 360 degrees. On the chart, your compass rose looks like that on the right-hand side, that magenta color. And on the compass, depending on what type of compass you have, you'll have the same, 360 degrees. And then sometimes you'll have those north, northwest indicators in the center of the compass. There are lots of different types of compasses. I'd say most recreational boats have this bubble type compass. So you might not have as many little ticks. You might not have all 360 ticks around the compass. If you have a larger vessel, you might have all of the 360 ticks, but maybe a little less accurate with the smaller compass, I guess I would say. But to keep in mind, there is the compass card, and that is the card that is always pointing towards north. And then the lubber line is going to be that line that is in line, the line that is in line with the center line of your vessel. So whatever boat you are on, there's that lubber line that is staying, pointed ahead, usually, pointed, dead ahead on your vessel. And then it's the compass card that seems to be moving, but it's actually the compass card that stays always pointing to north. And then the boat is moving around the compass card. So it's hard to visualize that because we're stationary on the boat and we see our compass moving if we are, going in a circle or something. But it's the boat that is moving around the compass. So that lubber line is what is moving, and that compass is the compass card is what is always staying pointed towards north. Does that make sense? Okay, so we have our lubber line and our compass card. Lubber line on this one is right there. Hard to see in that picture though. But the lubber line on the bubble compass is that yellow one. Okay. Again, another bubble compass. So we have that big lubber line. We don't have all, 360 little tick marks, but we do have the lubber line was pointing south. And we are, that bubble is moving around that compass card. That compass card is always going to be pointed to north. And when I say pointed to north, it's all dependent on what north we are talking about, which we are going to get into any second. Okay, so we have different types of compasses on board. The main type that you're going to see is going to be most likely your magnetic compass. And most likely you're going to see it in the bubble compass form. The other types, I guess I'll go into, is your gyro compass. Your gyro compass is this guy here. And then the gyro compass has repeaters. It's very hard to see what this is pointing at. So below it is the gyro compass repeater. So you can take your bearings, etc., from your repeater. And this little contraption on top of the compass is a very accurate way of taking those bearings. The pro to a gyro compass, well, pro and con, I guess I'd say, is that it is powered. You have to have electricity or power to run the gyro compass. And therefore, there's not as many things that can affect it besides not having power. So if you have a small compass error, not many things are going to affect it. Whereas your magnetic compass, which we're going to talk about today, lots of different things can affect that magnetism. You know, the magnetism on board, the magnetism in the area, can all pull the accuracy of your compass one way or another. So it's important to take that into account. But on board commercial vessels, at least, you will always have a magnetic compass, and they typically use it as a backup because there's no power involved. So it might not be as accurate as a gyro compass, but it doesn't need any power or anything behind it. So it will you'll always use it as a backup. Typically, it's on the flybridge, and you have this little, what is this? It's like the little submarine scope thing that reflects to the compass so that you can read it. And then this is called a binnacle. And then the balls and there's little bars inside can adjust for magnetism. So you can put little magnets and little balls, adjust it, you know, how close it is to the compass and stuff to adjust for other magnetisms. But you're not going to see that on your recreational boats. But that's how it is on commercial vessels. So recreational boats, you're typically going to see this bubble compass, and you'll also see sometimes that satellite compass, which has a digital readout typically. So you couldn't really get a use your satellite compass to find bearings of things, because it's usually just a digital readout. Okay. Question, has anybody used a gyro compass before? Has everyone used a magnetic compass? Most of us all familiar with our magnetic compass, right? Okay, that's what we're going to dive into today. But I just wanted to point out there are other compasses out there. And there's more than this. I think I had like one called fins on board. There's more than this. But this is your typical, your majority that you're going to see when you're out there. It's your gyro, your magnetic, and your satellite. For those of you testing with the Coast Guard, if you test with OCC, you won't get into gyro, but if you test other places, you will get into gyro compass errors. So just to keep that in mind, or if you test anything higher than 110, you will get into the gyro compass errors. So, okay. We went over the cardinal points. There's used to be 32, now we have 360. I put this one on here. At the end of this PowerPoint, we're going to get into the relative system. So there were, 32 points in our cardinal system for pointing to north. And then we have a relative point system. Relative means our 0 is going to be dead ahead. Our reference point is just going to be dead ahead instead of that north reference point. So there are lookout point systems. You can say how many points to starboard, how many points to port. These are just fancy ways of saying where things are pointed relatively to the bow or wherever. But again, most people, I would say for relative systems, use that clock method where they say, oh, something's passing at 3 o'clock or something, instead of, a beam to starboard or whatever. They use, typically, I would say the clock system is more recreational friendly than the point system. It all depends on who you have on board and what the communication level is. You don't want to be using the point system if no one else knows how to use it. So it's all about communicating well with your deckhands, your crew, and who you have on board. Okay. Any questions about the compass in general?
Yeah, just curious on the gyro compass, and I had my audio up for a couple of minutes. So does that give you kind of a magnetic reading based on the gyro, or does that give you true direction reading?
Neither. So it's not magnetic at all, and it's not true either. I don't know the complete mechanics behind it. I know there are things spinning in that big cylinder. So it has to do with that, I don't know, cylindrical forces or whatever it is. But it is pointing to a gyro north, which typically is much more accurate than magnetic. So typically your gyro compass error would be maybe half, 1 or 2, maybe 3 degrees. Where variation and deviation can be, 10 to 20, your compass error can be significantly different.
Okay. So it's kind of an in between, like more accurate maybe than the magnetic, but and less error than the standard deviation that you have with your true to magnetic. Okay, interesting.
Okay, so when we talk about compass error, we're talking about the difference between the boat's compass, whatever, like I was just saying, whatever boat's compass you're using, and true. So you have, could be your magnetic boat compass, could be your gyro boat compass, whatever compass you have that you're using on your boat, as compared to true north, as in geographical true north. That's going to be what we call compass error. So there's different things that can affect that. We're mainly going to be talking about our boat's magnetic compass. So kind of from here on out, we're all talking about the boat's magnetic compass that we have on board. There's 2 main things that can affect that boat's magnetic compass to pull it away from geographic true north. So when we say true north, it's, straight up on our chart. It's that geographic top of the earth. So there's 2 things that can pull away from that. We have 2 types of error. One is called variation, and that's going to be the Earth's magnetism. So the Earth's North Pole isn't exactly at geographical north. You have magnetism in the Earth's, fault lines and volcanoes and all sorts of other things. You have the Earth's magnetism that is affecting your compass to change it one direction or another away from that geographic true north. And then you have deviation, which is your boat's magnetism. So things on board can pull your compass away from that geographic or that Earth's magnetic North Pole. So these errors are introduced into what we are reading on board. So we see the boat's compass, and we see on the chart what true is. And if those aren't exactly lined up, we have this compass error. And they're the 2 types. We have variation and deviation. So I want us to think about kind of 3 different compasses that we are working with. We are working with our true compass, which is that, we have three kind of reference points. So our reference point for true is that geographic due north, right? That very North Pole. That's going to be our true north, always pointed up on the chart. It's that big star on the compass rose. That's on the chart. That's our true north, and everything, 360 degrees relative to that. Then we're going to have the magnetic North Pole. So where's the magnetic North Pole, and how is that magnetic compass, which we don't, not going to say we don't. So where's that magnetic north, or what is the magnetic compass reading? And then what is our boat's compass reading? So typically we don't have that magnetic north compass on board. I'll have a caveat on that in a second. But what is the boat's magnetic compass reading compared to all of these? So we kind of have different steps in our method of how we calculate where we're going and such. So we're going to kind of talk about those three different things to keep that in mind. Okay, so from our two types of error, we have variation and deviation. Let's talk about variation. So variation is again having to do with the Earth's magnetism. So it's the difference between the magnetic north and true north. The magnetic north and the geographic North Pole are not equal. And we can see that usually on our compass rose, we have the magnetic compass pointing on our chart, and usually it's to the right or to the left of that true geographic north. So right on our compass rose, we can see from where that compass rose is, where is that magnetic North Pole. So it's red right on the chart. Variation, Earth has different magnetic poles. Fun facts for you if you ever want some fun facts. Over the 9 million years, there's been 12 reversals of the Earth's polarity. So that's an interesting fact. Magnetic meridians are those lines of magnetic forces between the magnetic poles, and I'm going to show you pictures of that in a second. This is a cool image of mapping of the magnetic North Pole. I don't know how they really mapped it before 1904, but as you can see in the last century, it has kind of been taken off and moving. So it is not equal to the geographic North Pole, and it is always moving. So we do have this annual correction for variation because our magnetic North Pole is on the move. This is a picture of the United States and our magnetic meridians. So these are those lines of equal variation for different areas in the United States. This is it for the entire world. So as you can see, it's not evenly distributed. It's not like a graph line that you can be like, I'm 200 miles from this point, so therefore my variation is such and such. It's not like a calculated thing like that, I would say. So every chart that you are on, your variation is going to be labeled on the chart with that little correction of your annual correction, because the magnetic North Pole is moving. So I don't know, I want to say there's no like rhyme or reason to it, but I'm sure if there's a geologist in the class, they can tell us more about magnetism of the Earth. but I cannot. We all know that the center of the Earth is what, iron or some, anyway, I'm not going to go into it. I'm going to sound crazy. Okay. Let's go on. Our variation is found on the compass rose. So in this case, or let's start with the one on the left here. This is what it looks like on our San Pedro chart, San Pedro channel, or yeah, the San Pedro channel chart. So we have due north, again, that's that geographic due north with the big star, and our magnetic North Pole is pointing to the right of it. So it's saying our magnetic North Pole is 12 degrees east of the true north. So our variation is 12 degrees 00 east. And that was in 2017. Then it tells us right here that we have an annual decrease of 5 minutes, excuse me. So if this was given to us in 2017, that's, what year are we in? We're in 2021 now, so that's 4 years. So if we have an annual decrease of 5 minutes, that's going to be a total decrease of 20 minutes, right? That decrease of 20 minutes isn't going to push our variation to either 11 or 13. It's still gonna, we're still just gonna round it to the nearest degree, which is 12. So we're still just using 12 degrees variation. And I'm gonna say that is most common, that you don't have to stress about this whole annual decrease of 5 degrees or whatever it is, because it's not going to move your variation very much one way or the other. They typically get you a new edition with a new variation before that really affects you. So anyways, our variation is, pulled, our magnetic compass is pulled to the east by 12 degrees, and that's what our variation is. So we could, draw our line. We always draw that line from the center, right? If we were going on a certain course. And we can see what it's reading true, and we can see what it's reading magnetic. I tend to just use the formula for finding our compass errors, true compass, etc., instead of using this inner circle of the compass. But that is how I do it and how I'll teach it, but I just wanted to point it out there. This is a compass rose. I don't think this one is from our, no, it's not from our training chart. It's from someplace else. But it is saying that we have a variation of 4 degrees and 15 minutes to the west. So our magnetic is pulled to the west. You can see it's pulled that counterclockwise towards the west from true. So it is telling us that that is where our magnetic north is pointing. And again, it has the date and the annual increase or decrease. Any questions with finding our variation? Everyone see it on our San Pedro chart if you have that out?
So yeah, I'm looking on the training chart, and there's, like, found it on there, and I was going to ask, like, do these variations apply to the whole chart? But then I noticed that the different compass roses on any particular chart have different variations on them.
So you
So
want to
like
go
for that area of the chart,
Mhm.
maybe between that and halfway to the next one, the next compass rose, that's what you can count on the variation being.
Yes, you want to go with the compass rose variation from the nearest compass rose. So especially if you have one of those, smaller scale charts where you're, looking across the whole ocean, you'll have a couple different compass or, compass roses with different variation. And you might even have, I've seen some charts have those lines of variation on the chart so that you can figure out what your variation is that way, especially if it's, zoomed out and showing a large area of the world. So you're just going with whatever is closer. For us on our San Pedro chart, they all are 12. On the training chart, I'm not sure. With that being said, for those of you testing with the Coast Guard using training charts, they will give you a variation in each problem. They do not want you to read the variation from the compass rose in the exam. They want you to know how to find it, but they will, if you're doing a calculation problem for a Coast Guard exam, they're going to give you a variation to use. Coast Guard's just weird sometimes. For those of you testing, you might find it frustrating, but anyways, let's move on. I'm gonna find a picture of a chart with variation lines on it, because I know I've seen those. Okay, so our other type of error is called deviation. So deviation is going to be the difference between that magnetic, so you have your magnetic compass pointing to magnetic north, and then you have your compass card on the vessel pointing someplace else. So something is causing that compass card on the vessel not to point to the magnetic North Pole. So what type of things can cause deviation? Throw some things out there for me.
Pretty much anything metal or with iron in it that's near the compass.
Yes.
Tools or things like that.
Yes, anything, and things that you don't even think. A lot of us have our cell phones or our radars and computers, and all of those things can have a magnetic pull and pull the compass one way or another as well. But depending on the quantity and how much of something is, there can be magnetism in pretty much everything that you're going to have on board. So just to keep that in mind, you don't want to keep your toolbox or your pocket knife or something right next to your magnetic compass. But all of these things, your rigging, can all affect where your compass on your boat is pointing. So we need to take into account the deviation. And how we do that is by using a deviation table. So for this class, we have a made-up deviation table that we are going to be using. But in real life, I have some examples here. The one on the left is the format that the Coast Guard has on their website, so you could print that out and just create your own deviation table if you don't have one on board. This is an example from the book, and then the one on the right is an example from my husband's ship that they just got. So again, you have the ship's heading, and then you have a given deviation for that heading. So let me go to my okay. So you have your boat. I'm gonna try to draw a picture here. Let's see. See your boat, and it wants to, the compass card wants to be pointing to the magnetic North Pole. But whatever you have on board, maybe you have something back here. I don't know. You have something on board that is pulling your boat's compass card away from magnetic north. So it's pulling it one way or the other. Say it's back here or something. So any way that you turn your boat's heading is going to have a different effect on that needle, or that compass card that's trying to point to the magnetic North Pole. So if you have, something that's largely magnetic on your stern and you're headed in this direction, your boat's, north might end up over here if this is magnetic north. And here's, the big true north. If you have your big magnetism, over here, you might have less of a pull from your magnetic North Pole. So basically my drawing here is trying to explain that deviation depends on your heading. So it's not a constant, where variation is going to be this constant. No matter what heading you're on, your variation is going to be this overall umbrella. Where your deviation, again, that's something on board that's pulling away from that magnetic north, it all depends on what your heading is. So we're just going to keep that in mind. That being said, you can have a larger deviation on more of your, depending on what it is that's pulling on board. You might have a larger deviation on your east or west headings rather than your north and south headings. But again, you just have to apply your deviation so it works. Okay, let's go back to a picture. Okay, so we're back to the deviation tables, right? PowerPoint, see it, okay. So we have our heading, and then we have a given deviation. So in this class, we have two columns, one for magnetic heading and one for compass heading. And so whatever one we have, we can see what the deviation will be. Typically, if your deviation is above like a 5 or 6, then you probably want to get your compass adjusted. And there are professionals that do that. There are also professionals that will give you a deviation table, but you can make your own. And it is called swinging the ship to create your deviation table. And the way to do this is stay in a relatively stationary place and find 8 to 12 bearings around you. Or 8 to 12 aids to navigation or like points of land or, you know, significant things around you in all of the directions. So that being said, on the West Coast here, we don't have much to the east to take a bearing from, or to the west to take a bearing from. So it's a little bit harder, but what am I saying? You can take a bearing from that object and see what it is reading on your chart. If you're in a known position, you can see what it should be reading on, see what it's reading on the chart, see what it's reading on your compass, and compare, you know, get your compass error, apply your variation, and then you're left with deviation, essentially. I always like to say the visual ranges are great for this because you don't actually need a tool to get a bearing from. That if you have two things lined up, which we are going to go over in our LOP lecture, which is in 2 weeks. So I'm just going to touch base on that in 2 weeks. But that being said, to swing the ship, anywhere from 8 to 12 things around you, get a true bearing towards, see what your ship's bearing says, and then compare it. And that's how you swing your ship to create a deviation table. I'm sure there are lots of YouTube videos on that. I should find one and link it. I'm gonna write that in now. Deviation swing ship video. Okay. Okay. Any questions on deviation? Okay. Okay, so how do we calculate all of these things? This is where our math skills are going to come into play. We're going to put our arithmetic brains on here. How do we calculate these? This is where we're going to get into, I call it a formula. It might not be like a formula, more of like a poem or saying kind of math problem, if you will. But we are going to figure out how to apply these so we can see what we should steer per boat's compass and what we are doing true on the chart. So we have a formula here. We have TVMDC plus W. What does all those mean? We have true, so that's going to be our true course. Then we have V for variation. We're going to find that variation on the chart. Then we have M for magnetic. That's going to be our, magnetic heading, which is different than our compass heading, right? So that magnetic heading is based on the magnetic North Pole. Then we apply our deviation because our compass card on board is going to be affected one way or the other from the magnetic North Pole to see what our compass reads on board. And then we have our indicator. We have the add W, which means add west. So for each, I should have put this earlier. So if we go back to this our variation, this is going to be the same for deviation. Each value, variation and deviation, have a label, signifier, I guess I want to say. East or west? Is it, getting pulled clockwise, counterclockwise? Which way are we getting pulled? To the east or to the west? So when we go to our formula here, if our variation is west, and we're going from true to magnetic, variation is west, we're going to add it. If we are going from magnetic to true, we're going to add east. So it's kind of, if we work down, we're going to be adding west. If we work up, we're going to be adding east. So each variation and deviation have that signifier, east or west. And we are going to put this into practice today. So hopefully it'll make more sense when we do examples of it. So some
Bree,
people,
I have a question here.
Yeah.
So, I mean, another way to get the deviation is, I mean, if you have a GPS unit, GPS is going to be true north, right? And your GPS can also calculate accurate magnetic north. So it will know where you are in the world, and it will know where magnetic north is versus true north. So if you use your GPS and look at what magnetic north is on your GPS, that will be accurate magnetic north. And then if you would then look at your compass on the boat and see if magnetic north, or see the difference between magnetic north on your compass and true magnetic north, well, that's kind of an oxymoron, I suppose, but true magnetic north on your GPS, which is accurately calculated, you know what the deviation is.
I'm going to say that all depends on what type of GPS you're working with. What you were describing sounds pretty sophisticated GPS, where it's telling you where the magnetic north is. I haven't used a GPS that tells me that. So I would say, generally speaking, look into the GPS that you're using and that owner's manual, and it should say in there, the bearings or compass heading that it is giving you, is it in true, is it in magnetic, what type of unit or what type of degree is it giving to you, and then you can put that into practice. But that really all depends on what type of GPS you have on board. Yeah.
Thank you.
Yeah. Okay, so TVMDC, if you're going from true to compass, you're going to add west. If you're going from compass to true, you're going to add east. So sometimes people like to just write it going down or going up. Some people just rewrite it. CDMVT add east, TVMDC add west. If you have already seen this, use the way that you know how. I'm sure it's one variation of this or the other. I learned it C to T, but I would say most people have learned it T to C. So it all kind of depends on how you are visualizing it, but it is the same formula, if you will, either way. So from T to C, you're adding west, and from C to T, you're adding east. How do we remember this? These are going to be our sailor memory aids of how to remember TVMDCW. We have TV makes dumb children as our poem to remember this order. Add west. I would say the most common one that I have heard is not politically correct, but I'm just going to throw it out there. It is pretty offensive, but I like that it has it has our signifiers of east and west on it. So I throw it out there. We have true virgins make dull company, add whiskey and subtract ethics. So we have our add W, subtract east on there, which is helpful. We also have can dead men vote twice at elections? That's the one that I learned. So that's starting with your C going to your T, and you have your signifier of add east. Another one someone told me in this class was cow dairy milk is very tasty. That sounds kind of made up. I don't know. I mean, they all sound made up. What am I saying? Has anybody else, I'm curious, have heard of any other poems or ways to remember TVDMC? Has everyone heard of the TVMDC before? Is it kind of, okay. So in this class, I'm typically going to show you the TVMDC, add or subtract east or west, and go from there. But I can do it both ways, anyways, if you want me to redo it in one way or another. Okay. So if we combined variation or deviation, or we just, the other aspect of this is compass error, which is really just the difference between your true, not, you know, that's true north, and compass. So again, variation and deviation combined create that compass error. So if you just combine those two, you can get what compass error is. We label our variation, deviation, and compass error with a certain symbol. So we have east or west, to the right, to the left. Another way of kind of remembering that, another poem out there for you. Compass best, error is west. Compass least, error is east. So that's just another way of remembering it. These visuals I like to show. So we have 3 compasses on here. I know it's kind of hard to see, but I'm gonna try to explain this image here. So the outer circle is our true north. So we have the big star and it is going to true north. Then our next circle is our magnetic compass. So that magnetic compass, M, is giving us a variation that is to the west, right? Our variation, our magnetic compass is to the west of true. And then we have the ship's compass. So our big north on our ship's compass is pulled even more counterclockwise there to give us a westerly deviation. So we have a combination of our variation and deviation giving us our compass error. So our compass is reading this one, variation, and then true. So now I want us to look at a bearing. So we have a bearing here that is, I don't know, some object, you know, off our starboard side. And if I would to say, what is it bearing in true? It's bearing, you know, 039 true. Magnetic wise, the magnetic 0 is starting, you know, further away. So magnetic wise, it's closer to 050 true. And then reading it on our compass, it's getting even pulled further away. So our compass might be reading a bearing of 060, where in true, from true north, it might be only 039, 040-ish right there. So we talk about these reference points kind of moving, you know, east or west, to the right or to the left, but that affects the whole compass, because that's our reference point, where then we go clockwise 360 degrees. So that bearing is going to be affected by, and our heading essentially too. As you can see, our heading true is about 320, but our heading on our compass card says about 340. So that's about 20 degrees difference there, because we're getting pulled further and further to the west. Okay, this is another image of that, but we have variation and deviation pulling to the east. So again, you have your magnetic north pulled to the east. You have your true north pulled to the east is your magnetic north. Pulled to the east again is your compass card on board, and that affects your readings for your headings and your bearing of a certain object. This object is A. In this image, next image here, we have variation of west and a deviation of east. So in this case, we have our north, true north, pointing up, and then our magnetic goes over, I don't know, 20 degrees here to where our magnetic north is, and then our deviation is pulling us back closer to due north, true, or, you know, pulling us closer to the east. So we have numbers that can be, you know, one way and then go drastically the other, and then drastically the other way when we look at our TVDMC. So if you're just kind of looking at this, you can see the difference between our headings and our bearings as well. Before we go into practicing, let's take a quick break. Let's just take a 10-minute break here. Does anybody have any questions so far? Okay, cool. Let's come back at 7:40. So 5-10-minute break. I just need to take a breather for a second. All right, I am back. We're back. All right. Let's put these theories into practice. We will put some numbers into action here. And of course, we will do this together on the chart as well, but we'll just do some PowerPoint practice first. Okay, so we've drawn, you know, from point A to point B on our chart, and we have a true course of 045. We read from our chart that variation is 10 degrees east. So what course should I steer per compass on board? So I know what I want to do true. That was from the chart. So what do I want to steer per compass on board? So I write out my TVDMC, TVMDC. I put in for true my 045. I put in for variation my 10 east. So following my rule, if I'm going from T to C, I'm going to be adding west. And I have an easterly degree here. So that means I'm going to do the opposite. I'm going to subtract east. So I get a magnetic of 035. because I subtracted this east, because going down, I add west. If I have east, then I subtract it. So then I have a magnetic heading of 035, and I go to my deviation table to find what deviation to use. So I find my magnetic heading. It's always a range. So we have 028 to 038. We're going to use 3 east. So I put in my deviation of 3 east, and I follow my little rule here of going from T to C. I'm adding west. This is an east, so I'll be subtracting it. So I have a compass course to steer of 032. That is going to be my compass course. Now this little symbol here, I always like to get into the habit of putting the units next to things. This means per standard compass, or I like to think of it per ship's compass. So this is per the ship's compass on board. What are you going to be reading? Standard compass just means you might have different repeaters on board. Your standard compass is going to be the one that is center line. So sometimes you have your compasses offset for steering purposes or on the bridge wings or whatever. Your standard compass is the one that is center line. But a lot of people like to think of it as per ship's compass. So that's what PSC stands for instead of that magnetic. Okay, does anybody have any questions of how I did the math on that? How that formula kind of worked? We had 045, then our variation was east, and from T to C, we're going to be adding west. So we are subtracting that 10. We get 035. We got our deviation from the deviation table. We apply that. We're going to be subtracting it. So we got a compass course of 032 degrees.
Yeah, so I got kind of lost. I guess I'm not understanding. I followed the whole formula before, but it seemed like depending on which direction the variation is, you should just kind of move that in the same direction. In other words, if you have 10 degrees east, that's to the right of true north, right? So why wouldn't you add the 10 to the 45?
So
I was kind of looking at the compass rose, trying to see how it worked there, and it just seemed kind of backwards to me the way
yes,
this was done.
let me show you on this guy. Okay, so if we have true, and we are going, what was it, 045, right? Yeah. Here's our true. Here's our big star. And we are going 045. That's the line that we drew on board. And then it told us our variation. So I'm going to put another compass here. Our variation was, it told us to the east, right?
Yeah.
Is to the east. So that same line, our starting point of 0 is less than. That's why we subtract it. So if I was to draw this on my magnetic, this line is 035. Because my starting point is to the east.
Oh.
And then if I do that again,
yeah, okay, I think I see it now.
For my boat starting point is again further to the east. So the same line that I'm trying to follow here is going to be even less than what it is, because it's closer to that north, to that starting point for that specific compass, because our compass is starting further to the east.
Yeah, I guess another way I could look at it, now that you've done this, it makes sense. So your true heading is to the northeast. So you're already going partially to the east, and then you also have an arrow to the east, so it moves your starting point.
Mm-hmm.
So you have a smaller heading.
Correct.
That says, yeah, okay. Thank you. That makes sense.
Okay. So yeah, that number keeps getting smaller. Okay, let's do another one. Now we are steering on our boat. We're steering due south per what our boat says. 180 per compass course. Variation is 12. What is the true course? So what do I mark on the chart that I say what my heading is? So in this case, we have our TVMDC. I'm starting with my compass course of 180 per ship's compass. And I'm now going from C to T, so I'm going to be adding east. So I put in my value here of 12 east, but we're going to start with C. So my first step is to put in what deviation is. So I go to my deviation table. Under compass heading, I find 180, and I get a deviation of 1 degree west. So going from C to T, I'm going to be adding east. So that west, I then subtract it. So I get 179. Then I should have broken this up more. Then I'm going to apply my variation, which was given to me in the problem here, was 12 east. So again, I'm going from C to T. I'm going to be adding east. So I'm going to add that 12 degrees east. And I get 191 true. So I had subtracted the W, and then I added variation. So once we have this value, you can then double check if you want, go down the other way. TVMDC, add west. Does it make sense going that way? From T, I have 12 degrees east, so I would be subtracting it if I'm going from T to C. That makes sense. I get 179. If I'm going from T to C, I'm adding west. So I'm adding that 1, and I get 180. So you can go and check either way, if you're going from C to T or T to C. If one makes more sense to you than the other, or you just grasp the one differently. Just throwing that out there. Okay, so that's one going from C to T. Any questions with that so far? Is that making sense? Okay. So on both of these practices, we were talking about our courses, our headings, what we are doing. But there's another element to this. When we get a bearing or an LOP. Now and this is specific for deviation, our bearings, when we try to plot a position and we triangulate our position by getting bearings, those are different than, or can be, not necessarily always, but can be different than our heading. So our heading is where our bow is pointed. So if something is dead ahead of us, our bearing and our heading are the same. Any other time, the bearing of the objects is going to be different than the heading of the boat. So when we look at our deviation table, let me skip through this here. Our deviation table, is dependent on what our heading is, not our bearing. So if we were to get, you know, a bearing off of this light, when I plug it in, if I got the bearing using my ship's compass and I want to plot it on the chart, I need to convert it to true. Remember, anything that we put on the chart or we take away from the chart is always in true. So if I used my ship's compass and got a bearing to this light so I can triangulate my position, when I go to deviate, when I try to calculate my deviation with the deviation table, I use my heading. My heading is going to be different than my bearing. So we want to keep that in mind. We're going to talk about LOPs in 2 weeks, but what do I want to say about LOPs right now? An LOP is, let's go to my whiteboard again. So we have a light, and if I am cruising along and I see that light bearing 0.45 degrees true, there's my boat. I can be this piece of information of me looking at a light or an aid to navigation and getting a bearing to it. So I'm using, you know, some sort of compass on board. So I'm saying from north, this is, you know, 45 degrees clockwise. So I am saying, and if I draw that line, I'm saying I could be anywhere along this line. A line of position, this is an LOP. A line of position is an infinite possibilities. I can be right up next to it. I can be a quarter mile away. I can be 10 miles away. I can be anywhere along that line from that piece of information that said, I used my compass and I saw that light bearing 0.45. I can be anywhere along this line. It's infinite possibilities. So that's why we need to get a second. Maybe we have a buoy over here or something to get us a second LOP, and then we can know where we are. So all of these lines of position are just giving us a quick indication of where something is, I'm going to say bearing, where it is in relationship to north. So that being said, let's go back to this. Again, I like the visual range because on our visual range, you don't have to have an instrument to measure. Where if you take a bearing of other things, you have to use either like a handheld compass, your boat's compass, something to accurately measure where that bearing is, which is sometimes hard to do. And that's one of our most common errors or pieces of accuracy that make things less accurate, is the human error of how accurate was our compass and how accurate was our, you know, our reading of something. So we do go into that. I'm not going to touch this. we're going to talk about this in 2 weeks. Okay. I guess before I divert from this, if you are interested in taking the U.S. sailing certification class, which CoNav1 and 2 are prereqs for, then for that U.S. sailing certificate, they talk about having a magnetic compass on board. And so that's going to be what they consider a handheld compass. So they're saying that handheld compass, which I have a picture of in that slideshow that we're going to talk about in 2 weeks. But I don't have one here at home. There's some in the classroom, but anyways, if you have that handheld compass on, that handheld compass is always pointing to magnetic North Pole. So you don't need to apply your deviation. That deviation is only applied to your ship's magnetic compass. Personally, I think that's false, that any sort of magnetic compass can be pulled one way or another and have some sort of deviation, but it's not calculated on a handheld compass, and they just don't calculate that in U.S. sailing. But again, this is going to be up to you and the practices that you keep on board if you are going to be applying that deviation, which I highly recommend. But again, this is, I'm just going to say, up to you guys. So they're saying if you have a handheld compass and you're getting a bearing to an object that way, that is magnetic and not, and the deviation doesn't apply to it. And I think our number 3 or 4 on the homework assignment, I think it's number 3, we do a handheld bearing one where we don't have to apply the deviation. If you're testing with the Coast Guard at all, you always have deviation. And I think you have deviation in real life, but I don't know, some people don't calculate it. Anyways, okay, let's go to relative. So for the last 2 hours, we've been talking about things from north, that 0 was north, whether it be the North Pole, magnetic North Pole, or your compass card's north. That's where 360 degrees come. So if we change this to a relative bearing, we're going to change it to the bow of the boat is going to be our 0. And then going clockwise again, so going to starboard or going to clockwise is going to be a relative bearing. So it's sometimes easier to communicate to your crew, or they might not know where is north. I'm not looking at a chart, or I'm not looking at anything. I've no land to give me a reference to where north is, or I'm in a new area. I don't know where north is. I just know where the bow of the boat is, and I can give you a relative, something's 45 degrees off the bow, or something's off the stern, a relative indication of where that is, instead of a true from that north, that, if you're not looking at a chart or something, that you're not, seeing it with your eyes visually. So relative. Here's an example that our ship's heading is 045, right? We are 045 from due north. So if I was looking at this lighthouse, I would say it is right on the starboard beam. It is 90 degrees to starboard. So its relative bearing would be 90 degrees. Now, if I wanted to plot that on the chart, I would want to apply what my heading is and that 90 degrees to plot a true bearing, because anything that we plot on the chart is going to be true. So I can say that the true bearing is 135. I'm adding my ship's heading plus my relative heading to get what the true heading of this specific light is. I'm going to say we use in our second to last week, we're going to use this in like a bow and beam kind of quick way of getting a calculation, but it isn't used very often, so don't stress about it too much. But your relative is just saying that your starting point is 0, or your starting point of 0 is the bow. So if you want to calculate from true, you have to apply your ship's heading, which is from 0, add the relative bearing to get what the true is. So you adding 045 plus 090 to get what the actual true bearing of that light is. This is another image of it. Again, you have your heading, which is from north, and then you have your relative bearing. So that's just from your bow of your boat to the object in question. If you add those together, you get your true bearing. So this is going to be a couple examples of it, but this is my poem, if you will, for calculating relative to true bearings. So you have your relative R plus S equals T, RST. Your relative bearing plus your ship's heading equals your true bearing. So we can go to an example here. We have our ship's heading, which is in the green of 045. We have the relative bearing 135. If we add those together, we get the true bearing of 180. And again, you can do that for any of these examples. I do like to do the one where we get a very large number. So we had our ship's heading of 045, from due north in the green, 045. And then our relative bearing, it always goes clockwise. So we go clockwise 340 degrees to get what this relative bearing is of object D. And we get this huge number of 385. 385 doesn't exist, so we have to subtract 360 from it, and we get 025. Another way people like to do this is say, instead of getting a relative bearing of 340, maybe say a relative bearing of -20, meaning it's 20 degrees to the port instead of 340 degrees to starboard. That's sometimes easier, so you just subtract the 20 degrees. That makes sense too. Whatever way you can visualize it works. Okay, so we're going to dive into our plotting. Assignment 5 is going to be our plotting with TVMDC on the San Pedro channel chart. Assignment 6 is a little exercise on relative bearings. I'm going to say that it's phrased a little bit weird, but give it a shot. The answers are posted. And then assignment 7 is just a bunch of practice of moving through the formula. TVMDC, finding the missing values one way or the other. So it's just moving through the formula and practicing that. Any questions before we get into our plotting? All right, well, let's,
Is there a
give me-
typo on that? Was there a typo on that last chart? Was it TVM DC instead of CD there?
yes, there was.
Okay.
That is correct. The C is at the end. I'm editing that now. Okay, maybe I'm not. Yes, there we go. Let's get out the charts and our assignment 5. And I will share my screen. Okay. Okay. So for assignment 5, for number 1, move this over. Make sure you guys can still hear me. Sometimes if I'm not close to the laptop, it doesn't pick up my voice. Okay, so for number 1, it tells us we are sailing on a course. So we are on a heading of 298 PSC. At 8:30, we take a bearing using the ship's compass to find Hoag Hospital. Bearing, that's the symbol for bearing. 061 degrees PSC. And the PowerPoint Southeast stack, I'm just going to call it stack, bearing 007 degrees PSC. So if you are, putting this down in your logbook or something, you could just put this, just put that in your logbook and then you can plot it. Or you can convert it to true if you want. Just depends on how you keep your log. But anyways. So this is the information they give us. And then we want to plot our position with our latitude and get our latitude and longitude and put in what our true course is. So we can see where we're going on the chart. So where are we and where are we going? Okay. So for all of these types of problems, I like to set up a table. So I go with my TV MDC, add west, subtract east, and then I will make a little chart here. So I'm going to have my Hoag Hospital, my stack at HB, and my heading. So I'm gonna plug in the information. They told me that Hogue was bearing 061 degrees. My stack, the stack is bearing 007, and my heading was 298 degrees. So I'm gonna work my way up. So if I'm going this way, I'm going to be adding east and subtracting west, because I'm going from C to T. So my first step here is to see what my deviation is. So I go to my deviation table, and again, I'm looking at heading. So I have my magnetic heading and my compass heading. My compass heading was 298. So I'm gonna find what is my deviation. So I have a compass heading 285 to 298 gives me a deviation of 6 degrees west. I know that's hard to see on there, but hopefully everyone has this deviation table. It should have been printed out with the handouts. If not, it is on the Google Classroom. You could print it out again, but it's what we use in both coastal nav classes. Okay, so our deviation was 6 west, and that is applied across the board. Again, because our deviation has to do with our heading. So it is applied to all of them. So our deviation, marker here. If I'm going this way, I'm going to be adding east, subtracting west. So I'm going to subtract that 6 degrees. Here I get 055 degrees magnetic. Here I get 001 magnetic. 292 degrees magnetic. You guys will all catch me if I get my numbers wrong, right? And then I want to see what is my deviation. So where do I find deviation? Down here on my compass rose.
That's variation, right?
Variation, excuse me, yes. Deviation was on our table. Variation, we're going to find on my compass rose. So I have 12 degrees east. Is my variation. So I will apply that. And again, I'm going from C to T, so I'm going to be adding east. So I'll be adding that number. And I get new values here of 067. That is 013. And this is 304. True. So now I have my true values that I can plot on the chart. So now I can go to the chart. Go to chart. That says go. Okay, so now I'm going to use these values to get my position and then plot where I am going. So let's put that aside for a second. I'm going to use the triangle first, but I can do it using the roll plotters as well. Yeah. Okay, so Hoag Hospital. But first we want to identify our things that we saw. So Hoag Hospital is going to be this building. It says building and then hospital. Right off Newport Boulevard there. That's our Hoag Hospital. And then our power plant stacks. We have in Huntington Beach, we have 2 stacks, and we are going with the southeast one. So the southeast stack is the object in question. So for the hospital building, I'm going to find, so I'm going to put my pencil on the hospital building, and then I'm going to line up this focal point on a vertical line. So here's my vertical line and close vertical line. And then I'm going to find on the edge of my triangle a 0, 6, 7. Right there. So as you can see, here's that vertical line. Here's 0, 6, 0, 0, 6, 5, 6, 7, 8, 9, 70. So I have my pencil was on here, and I had a pivot point, my focal points on the line in question, and I will draw in my line. So I know I am somewhere along that line. If you're using a roll plotter, you can find 0, 6, 7. There's 0, 6, 7. And you can just push down and roll your way up and draw in your line. My stack is 0, 1, 3. So again, we can do that with the roll plotter here. Here's 1, 2, 3. All right, there's my 0, 1, 3. Put my pencil on the stack and draw in my LOP. Oops, you can't see the stack. For the triangle.
I'm sorry, you said 0, 1, 3 you were coming down from the stat?
Correct.
It says 0, 0, 7, or am I reading?
So we converted them all to true.
Ah, okay, so we got to read that off of, right.
Yes.
True. Okay.
We did 0, 6, 7 for Hoag, 0, 1, 3 for the stack. And then I could plot my heading of 3, 0, 3, 4. So where these two lines meet, that is my, we're going to put it right here, 0830 position. And then I am headed in the direction of 304. So I will plot .304, and I am on a course of 304 degrees true. So I'm here and I'm headed this direction. There's me. I got my 2 bearings and I could see where I'm headed. So I wanted to put in on the chart what my heading was in true, even though I can say in compass it was 298 per ship's compass. It was 304 true. So the next part of this question to check to see if we're accurate is to see what our latitude and longitude is. So I've gotten a position and now I'm going to see what my latitude and longitude is. So I'm going to draw in my latitude.
So let me ask you a question before you get there.
Yes.
If you've got, if you're magnetic, can you go back? You said your 304 compass and 298.
Yes.
True, no, your 304 true.
Correct.
And 298 compass.
Yes.
But if you look at the compass rose, the magnetic reading is larger than the true reading. So why does it reverse?
Let's see, so our true is 304.
Oh, but I mean, just in general, true is 0, and you've got 12. You add 12 degrees to get to magnetic, right?
Yes. So this is kind of going back to
I guess
to
my
that.
only point here is that, you know, per ship's compass should be greater than the true heading, not.
So it's actually opposite of that. Okay, so here's our
So if
compass,
you're
right? So my ship's compass is my small one here. I'm going 298, right? So use the backup piece of paper. So I'm going 298 degrees PSC. And my north isn't exactly due north, right? This is due north. My north is to the, what is my variation? To the east, right? So I'm going to put my north is to the east. Are you following me? So that pushes my true, if I want to find true, over to the east, which would make it greater.
Okay. But at the top, true is less than magnetic.
True is 304.
No, but I mean, true north is 0 degrees, right?
Correct.
No, not that one, but 0 degrees. And magnetic is 12 degrees.
Correct.
Right?
So this is our magnetic.
So if you rotate magnetic to the left, if you just rotate it counterclockwise, shouldn't the difference between your true heading and your magnetic heading always be 12 degrees if you ignore deviation?
So why are we going to go counterclockwise?
Well, I'm just saying, if
it was to the west?
yeah, let's go to the west.
Okay. Hypothetically.
If you well, let's just say if you rotate 90 degrees to the west, you'd be your true heading would be 270, right?
No, our true heading would be closer to north.
I mean, not your heading. I mean, if you're okay. If you
So-
Maybe you can look at.
okay, so if your magnetic heading, if you like go back, okay, if your magnetic heading is 12 degrees at 0 there, right? What is your magnetic heading going to be if at 270 true?
Okay, so let me get another piece of paper. So we have our true compass,
Right.
270.
Yep.
So our
And we know from our compass rose that 000 is actually 012 magnetic.
so are you saying our compass, our magnetic is to the east or to the west?
It's to the east. On the compass, it's
On the compass.
true north is east.
Is east, right? So our
Right. So it's
zero,
zero.
this is our magnetic north pole. So this whole thing rotates.
Oh, of course.
So
Okay.
270 magnetic is over here.
Okay.
So if I wanted to read, if I had an angle, my object was over here or something, my light, whatever, it's going to be in between that magnetic 180 and 270. It's going to give us like 235 magnetic.
Right. Well, okay. I'm just saying magnetic is 12 degrees in, a true north, east of 000.
Correct.
At 270 true, what would you expect magnetic to be?
So if something is bearing 270 true, it is now, my 270 is over here. So that would be magnetic 258. Magnetic. Because my 270 has shifted
Okay.
clockwise.
All right. Okay, I'm with you now.
It's all rotated clockwise, east.
Okay, thank you.
Okay. Just takes some clarifying sometimes to visualize that. So we were getting our position for our 830 fix. So for latitude, I drew in my 90-degree lines. So I get my latitude and walk it all the way over. And get my longitude. I'll write out our answers here. And walk it all the way down. And we have a position is our actual position. If you're looking at it, let's put that there. Oops. I want to put it here. I am right in between. There's like a 13, 13, 15, and 17 sounding. I want to say, is it 15, 13, 13, 17, so right here. If you were looking at it via the soundings, that is where I plotted mine. Try to show you on the chart better. How'd you guys do with that one? Okay. All right. Let's move to, so that was all of our work for number 1. Let's move to number 2. Okay. So for number 2, they give us a heading of 107 PSC at noon. We had Point Vicente bearing 314 degrees PSC, and Point Furman bearing 044 PSC. What is our position and heading? And we should plot it. So again, I like to make my little table. You can, start with C. I think most people start with their TVMDC. We'll be adding west, subtracting east. So that's our rules. We'll make the table. We have Point Vicente, Point Furman, and our heading. So what did they tell us? They told us per ship's compass, they're giving us values of C. Point Vicente is 314 degrees. Point Furman was 044 degrees. And my heading is 107 degrees. And I am going from C to T, so I can plot it. So I'm going to be adding east and subtracting west. So I start with what I know, my C's, and I want to put in my D, my deviation. So let's go to our deviation table. And what is our deviation? Shout it out there. What do we have? 107 was our compass heading. So we have compass heading 093 to 108, gives us a deviation of 5 east. So I have 5 degrees east, 5 degrees east, 5 degrees east. Again, I put this the same all the way across because our heading didn't change. We got our bearings and our heading stayed the same. And our deviation is based off of our heading. So if I'm going from C to T, I'm going to be adding east. So I'll make a little plus. And now I'm going to apply that number to get what my magnetic is. So I have 319, 049, and 112 degrees. Then I have variation. Again, we find that on the chart. So we have a 12 degrees east variation. If I'm going from C to T, I'm going to be adding east. So I'll be adding 319, true, and 12 and 49. 60, true, and 12 and 12 gives me 4 degrees, true. So I have my true values to go to the chart. So again, I always plot on the chart my true. So I'll be using my 331, my 061, and my 124 to plot it on the chart. Okay, gotta move my camera here. Harder to get over my table. Okay. We got point Vicente and point Furman. Okay. We can see that. Okay. So, again, we are using the values of true. So, let's get our 331 for point Vicente. So we have point Vicente light. We're using that dot, that solid dot as our point to put our pencil. And I don't know if we're gonna reach it. I don't think we are. So this is in case you're using a triangle and you can't reach. This one clear? Don't know where my clear one was. Anyways. So I want to find 311 and I want to bring it over to point Vicente. So I'm going to use this vertical line and just find 331. So here's my focal point on the vertical line. And oops, that's 336. 331 on my triangle, focal point on the vertical line. And I want to move the triangle. So moving the triangle, use the short sides. So I'm going to put pressure on the triangle that I measured, bump up a straight edge. It doesn't have to be another triangle. It can be a ruler. And move over to Point Vicente. There we go. And we're going to put in our line. So there's our LOP. Point Furman was 061. So I'll put my pencil here and find 061. There's my 061 focal point and pencil. So I'm going to say this is my 12 o'clock position. And I'm headed in the direction of 124. Put my pencil on my position and find 124. I guess you can't see it on my screen, but there's my 124 degrees true direction. So I am headed south here, or somewhat south. Try to make that darker. Maybe it's my pencil. Okay. So I did that with the triangle. I can also do that with the roll plotter. We have a compass rose over here and a compass rose over there. Both are hard to move with my camera setup, so maybe I won't do it. But to get the latitude and longitude, we are close here. I will put in our position. Where'd my red go? There it is. We had 12 o'clock, 330 degrees, 40.4 north, and so there is our position using that Point Vicente and Point Furman LOPs that we converted from compass to true, and then we put in our heading line in true. Don't know where my other boat is. So there's our boat. Oh, and there's my triangle.
Bree,
Yes?
would you mind very quickly showing the triangle, how you got the 331 again?
Yes.
Great. It's just like in 2 seconds. I just missed part of it and I couldn't replicate it.
So I couldn't reach, right, using everything lined up. So on the vertical, I put my focal point and 331. So there's 331 and the focal point on the straight line, the vertical line. And then I use a ruler or any sort of straight edge to move my triangle. So I'm going to put pressure on my triangle, bump up a ruler against it, and then I can move this triangle. This angle hasn't changed, that it's still 331. So I can move it anywhere. So then I put my
You
pencil at
just
point
move it to the
percentage.
point of reference then. Got it. Okay.
Yeah.
Sense.
Yep. So I would say about 70% of the time, you don't have to move the triangle, but then there's that 30% that you do have to move it. So that happens when we have a LOP or a course line that's close to, due north or due south, or we have our object that's kind of right in the middle of two vertical lines, like Point Vicente is. It has less of a range. All right. Kind of did this quickly, but any other questions with number 2? Okay, I'm gonna take another 5-10 minute break here. I'm gonna leave that here so you guys can see it. But I'll come back at let's do 5 till 8:55. All right, I'll be right back.
Can you show the answer again of the location of the last one?
Did you want to see the whiteboard or the?
Yeah, the whiteboard where you came up with the answer. 33, 40, yeah, 118, 21. Yeah, okay, got the same thing.
All right. So this. Oops. There we go. Okay, so let's do number 3. All right, so number 3 says 1800. We are using a handheld bearing compass to take a bearing of 234 magnetic, ship's rock, and 157 magnetic at long point light. Your heading is 100 degrees PSC. Okay, so this one they told us by hand. So, and they gave it to us with an M. So those are both little flags here that we are going to enter the table. Let's see, just looking for our time. 1800, we had ship rock, bearing 234, magnetic, and long point 157 degrees magnetic. Our heading was 100 degrees PSC. Do you guys have 100 PSC on your homework assignment?
Yeah,
Okay.
I do anyway.
That was edited a while ago. I just wanted to make sure we all
Yes,
had
we do.
the same. Okay. So again, we go to our table. We want things in true, so we could put it on the chart. TVMDC. Add west minus east. And we have ship rock, long point, and heading. So when we put this into our table, both of our bearings were given to us by a handheld compass, which means that there's no deviation. And it is given to us as an M, which goes in here. So we have ship rock at 234 degrees M and long point at 157 degrees M. And then it told us our heading was 100 PSC. So we want to continue filling out our chart so we can get everything in true. So for our heading, we do have to apply deviation. So for 100 compass heading, I get 5 east. Answer sheet says 4 for some reason, but I'm pretty sure it's 5. Unless I'm going crazy. I don't think I am. So if I'm going from C to T, I'm going to be adding east, subtracting west. So I will be adding that east. I get 105 degrees magnetic. Then I'm going to apply my variation. I look on the chart, get my variation of 12 east. And I am going this way, so I'm going to be adding east. So 234 plus 12 gives me 246 degrees true. Yeah, that's right. 157 plus 12 gives me 169 true. And then my heading of 105 plus 12 gives me 117 degrees true. So I have my true values that now I can plot. Plot on chart. So I can see what I'm doing on the chart. So before I move on here, this is an example. We're not going to have really any, I don't think we have any after this. But if you are taking the U.S. sailing endorsement, they do some where they give it to you as magnetic and tell you it's a handheld compass, and some that they tell you you got from your ship's compass. If you're taking Coast Guard exams, it's only ship's compass. But throw that out there. Okay, so I'm going to use these values and plot this position. So we are Catalina here. Move my camera over just a little bit more. Okay. Okay. I have this big desk, but I still make a mess of it all the time. Okay, so we have Ship Rock. That's over by Isthmus, Two Harbors. And Long Point is that point that sticks out on Catalina, is our long point. So these are our two objects. There we go. Focus that. Okay, so we have 246 for Ship's Rock. So I'll put I'll go this way so you can read it. Here's my vertical line. Put my pencil on Ship Rock, and I'm looking for 246. So there's my 245, 246. Focal point there, and I can draw my line. Don't know if I have to go any further, but I will, just in case. Okay, so there's my 246, and then from Long Point, I have 169. That is very close to vertical, so I know I'm going to have to move my triangle. So I'm going to find 169. One, 168, 169. Oops. So I have I have nothing on Long Point. I'm going to move my triangle. So I have my focal point on the vertical line at 169. Then I'm going to bump up a ruler, move it along to Long Point, and draw in my 169 line. So right at that sounding of 494, maybe a little south of that, that is my 1800 position.
Could you do that again with the triangle real quick? I was looking at my chart, trying to do it myself.
Yep,
And
yep, no problem.
Slide.
So I have my focal point on the vertical line.
Yeah, I can see it.
So I'm not doing anything with Long Point at this point. I'm just doing the vertical line. Focal point and 169. So there's 160, 170, 169. So this angle here is 169. And now I can bump up a ruler. Here's my ruler. So any sort of straight edge. I'm going to put pressure on my straight edge now. So that's kind of my little anchor. And now I could move my triangle. Of course, my camera's in the way now. Until it gets in line with Long Point, and then I draw my line.
Okay, thanks.
And then I had a course line of 117. So I'm going to put my pencil on my position and find 117. and draw in 117 degrees true. So I'm here and I'm going 117. So if you want to, clean up your chart and not have all these lines around it, you can, erase these long bearing lines. You don't have to keep those there. In fact, when you're drawing it, and relatively like where you are, when you're drawing it, you can either do dashed lines if you want, or just draw a line in your general vicinity. That way you don't have giant lines across your chart. As you can see, I have a lot of lines on my chart, but I try to erase them. Anyways. Getting our position. So we're going to move that slightly. Plot. Our latitude and longitude. And I will write it in here.
Isn't the heading 107?
No,
100 minus 5 is 95. 95 plus 12 is 100.
we're going to be adding east. So we had 100
Adding east. Oops. Okay, sorry. Yep.
plus 5. I was like, wait, did I do my math wrong? I'm pretty sure. Yeah, 117. Okay. So our next one, number 4, is a little jump ahead to, what are we on, week 3 before week 5? When we talk about LOPs, because in this one we actually don't do any compass error, but it is a fun problem. So let me explain it, and then we'll plot it on the chart. But it is saying that we have a our LOP this time is instead of a bearing to an object in degrees, it is going to be a distance from an object. So the most accurate way I know how to do that is using a radar. Some vessels that you're on might have radar, some might not, but that's the most accurate way I would calculate a distance or measure a distance and use it as an LOP. So if you got a distance from this point of land of, let's say 3 nautical miles. My LOP with this piece of information is saying that I am somewhere. If I had my boat, I'm cruising along, and I got a radar range from that point of land to say 3 nautical miles, that piece of information is telling me that I am somewhere along this line, and this line is an arc or a circle, if you will, because from this, from the object is 3 nautical miles. So that circle that I drew has a radius of 3 nautical miles. So I could be somewhere along this line of position. So just like a bearing, I need another piece of information. Now, the quick way to do this with using a radar is to use that same point. So I can say my distance from that point was 3 nautical miles, and my bearing was, what am I going to say? 310 degrees true. So I have infinite possibilities along this line and infinite possibilities along this line to say this would be my position. And I got a range and a bearing. So range and bearing to one aid to navigation is a very quick, simple way to get a position using a radar. A lot of times you don't have radar on board or you're not using it, but that's a very quick and easy way to get a position. So that's using 2 different LOPs, using an arc LOP and a line LOP. Now, the question number 4 that we have is actually using 2 arcs. So it is saying we had a certain distance from, I think it's a buoy and a platform or something, but let's just say we have a buoy out here, and we have another arc. Let's make this a little bit closer. Now it's a light. I changed it. So we have another arc that says we are 4 miles from that light. So this isn't here anymore. We just have 2 ranges. We had a range of 3 miles from this light and a range of 4 miles from this light. Both of these are LOPs, both of these circles, and they cross in 2 areas. So we have a possible position here and a possible position there. Because both LOPs, we have an LOP, we have an LOP. Again, that's line of position. And anywhere those 2 LOPs meet is our possible position. In this case, we have 2. So we need a 3rd piece of information to tell us, are we over here or are we over here? So that information can be you looking out the window and saying, hey, I'm really close to shore, or maybe that is ruled out because the land goes like this, and you're like, well, I'm not on land, so I must be in this one. It can be like, oh, I know I'm south or east of that buoy. I haven't passed it yet, so it must be on one side. So it can be as simple as looking out the window. It can also be, which we're going to use in this question, a depth. So maybe it's 100 feet out here, and maybe it's only 20 feet sounding over there. Maybe it's a bearing that you got a range and bearing and another range. So you just need some other piece of information to tell you which position you are at. So let's plot that and see what we get. Does that make sense before I move my whiteboard? Okay. So for number 4, they are telling us at 9:45, we have oil platform Eva has a range of 3.9 nautical miles. And then our buoy which buoy is our Long Beach buoy, has a range of 3.5 nautical miles. And then we have a depth of 100 feet. What is our position? Okay, so I am going to use the instrument where I have a pencil end and a pointy end. So that's called our compass. So I can draw the arc. Especially if you're at your dinner table or something, I recommend not etching an arc into your dinner table using the 2 pointy ends. But let's use pencil. Okay, so I'm going to get a distance of 3.9. Use my side of the chart here. 1, 2, 3.9. Okay, so oil platform. There we go. So here we have our oil platform Eva, which is right here. And then we have our Long Beach buoy, which is over here. So this oil platform, I have a range of 3.9 miles from it. So I'm going to draw an arc. It says I'm somewhere. You don't have to draw it this big. I'm just being dramatic for the sake of it. That I'm somewhere along that line. And then I have 3.5. Look at me, I already did it wrong. That was 3.9, right? Oh, that was 3.9. Okay. 3.5. From the buoy over here gives me this arc. So I have 2 possible positions. Over here or over here. So that third piece of information they gave us told us we have a sounding of about 100 feet. Now on our chart is in fathoms. So what would 100 feet read in fathoms? I like to use that little table down at the bottom. See if my little thing will reach.
16.6.
Yeah, that little guy. I'm looking at 100 feet. I'm looking at about 16 to 17. There we go. So over here, I have a fathom of 7 or something, I can't read it. And over here, I have a 17, 16, 15, 17. So I'm going to say that this is my 9:45 position. So hopefully I know by looking out the window that I'm not, you know, at the entrance of Huntington Harbor over here, that I'm a little further offshore, so I can just assume that that's where I am and not way up there. But for plotting wise, you know, in this fictional plotting world of practice plotting that we are in, we had no idea. So we need that extra piece of information. So from there, we're going to plot our latitude and longitude. And our course. They didn't give us a course. Okay. They didn't give us a course. Okay. Any questions on plotting those ranges as LOPs? Again, we're going to do more of that in 2 weeks. Okay. Okay, for the last 5 minutes here, I wanted to touch base. So I'm going to kind of leave number 5 with you guys. You guys can plot number 5. Number 5 is going to be a range and a bearing. So you have one bearing that you convert and one range. So one arc, one line. But on assignment number, can I spell assignment? Assignment number 7. So assignment 5, I left you with one more problem to do. Assignment number 6 is a quick little exercise in relative bearings. Again, relative meaning having your R plus S equals T. So your ship's heading plus your relative heading equals that true bearing. And then number 7 is an exercise of just converting compass to true, true to compass, so forth. But I wanted to touch base on the last couple down at the bottom. We're going to do number 19. 19 together. I'll read it here before I explain it. Okay, so number 19 says, you are cruising on a compass course of 118. So I'm going to say, what is this? So I'm cruising on a compass course of 118 degrees PSC. And you wish to return to your point of departure. So you wish to head back. What is the compass course you should steer on your return leg? So step number 1 on this is I have been heading along this track line here of 118 PSC. I want to convert this line, it's the same line here, but what is it in true? So that I can correctly make my reciprocal, go the opposite way. So I want it, my step number 1 is to convert this 118C to true. So I'm going to use my TVMDC. I have 118 PSC, and I want to go to true. So I'm going to be adding east, subtracting west. So I'm going to use my deviation table and find a deviation 118. Gives me a deviation of 4 east. I'm going to be adding east. So I have a magnetic of 1, 2, 2. Variation is given to me in the question of 14 degrees east. Again, that's just given to me. So I'm going to add that, and I get a true course of 136 degrees true. So this line here is 136 degrees true. If I want to do a reciprocal of that, I would add 180 degrees. So 136 plus 180 gives me 316 degrees true. So my reciprocal on the way home is going to be 316 degrees true. That's that same line. But now I want to convert this to PSC, to compass. So I go back to my TVMDC, and I'm starting with my 316, and I want my compass. So I'm going to be adding west, subtracting east, and I'll plug in my numbers. I have 14 degrees east, so I'll be subtracting that, and I have 302 degrees magnetic. Go to my deviation table and find 302. Gives me a deviation of 5 degrees west. So I have a totally different deviation, meaning I have a totally different compass error. I'm going to be adding that west. And so my compass to steer is going to be 307 degrees PSC. So going this direction, I am going 307 degrees PSC. We're going that direction. I was doing 118 PSC. So it's kind of this puzzle here where I want to follow the same line that I'm on, right? I want to follow this line that I've been going on. I want to go exactly backwards, but I don't know what that line is true. So we had to convert it. What are your questions about this?
So if I took and added 180 to the 118, I'm not getting the same number. Is that because the variation is different?
Correct.
The deviation is different
Deviation.
because your heading is different.
Correct.
So it's not kind of just one for one. It could be the same, I guess, depending on what it is for your boat, right? If it happens to be the same 180 degrees the other direction, but
Yes, but that's
Not
not very likely,
Yeah, okay.
right? Your deviation is based on your heading, so that,
Yeah.
you know, wherever your big magnetic spot is, you know, on your boat is pulling your boat's compass card one way or the other.
Right, yeah. That's interesting, because I did it in my head. I said, oh, it'd just be 298, but there's
Mhm.
other factors.
Yes, there are other factors.
Okay.
All right. So that is your guys' homework assignments. Again, the answers are and videos are on the Google Classroom. Next week, we're going to be diving into speed, time, and distance, and that equation and that formula. And then the next week, we're kind of putting that all together of LOPs, speed, time, and distance, DR plotting, and kind of putting both of those skills together. So this week was all about compass error, and next week is all going to be about distance, speed, and time. Let me know if you guys have any questions along the way, and I also jump on at 5:30. So if you want to touch base before class, I'm also available. But that's all I got for you guys. Any questions? Are you guys doing good?
Hey, thanks. That was really cool.
All
A lot of
right.
cool stuff tonight.
All right.
Thank
I like it.
Thanks, Bree.
All right, you guys have a good one.
Hey, thank you, Bree.
Marie,